Advantages and pros and cons of NAT. Advantages of NAT are conversions conserves the legally registered address scheme. It means that it is saving a range of available IP version 4 addresses, increase the flexibility of connections to the public network, provides consistency for internal network addressing scheme, and provides network security due to that fact that no one, excluding router, your own router where you make NAT translation, knows about the original IP address which you use in your local area network. And disadvantages are performance is degraded due to that fact that our router have to make additional calculation, additional memory usage for this NAT table, and and also one of the disadvantages is end-to-end functionality is degraded. And again, why it is degraded? It is degraded due to that we have impact of the NAT. End-to-end IP traceability is lost because we don't, for example, if in local area network there are a lot of routers, but when we are making trace route, we can see only public trace routes. Tunneling becomes more complicated, so maybe you still don't know what is the tunneling is, but you will see that NAT is making tunneling be configured with more details, and it is taking time. And initiating TCP connection can be disrupted. Now let's take a look with you for the port forwarding example, where we have the client which is placed in the public network and which wants to have access to private area to the private network in which we have multiple servers, or maybe even single server, but in our example it will be a multiple servers. Now let's take a look first of all to IP addresses of the client and the server. The IP address, the original IP address of the client is looking like this. The original IP address of the server is looking like this. So that when our computer wants to make connection from the internet to the local area, so to the inside network, our computer have to contact one of the public addresses which are available to it. Okay, it's not able to make communication directly to the local area network's IP address. And then we can create a NAT which will make translation. So when someone will try to enter to this IP address by using a defined port, then it will make retranslation to another IP address to also predefined port. So as you know, when we have a web server listening for port number 80, listening, and we can open the web browser, and in web browser we can type an IP address like 209.165.200 and 225, and then after column we can place here the port number 8080, for example. Well, when we type this command, our client will make request to the router. Router will take a look for the destination IP address, which is looking like this, and the port number, so it is actually called socket. And by using this socket, our router can make retranslation to IP address 192.168.10 and 254 to port number 80, which is on listening port. So it is done by using command in the router to ipNAT inside source static, and instead of immediately placing here the inside local IP address, we can first of all define which port which protocol's port will be translated. And we say that TCP because it is reliable and because it is working with the HTTP. And HTTP is actually web, as you know. Well, we are defining with which protocol ports will make translations, and then we are defining inside source IP address and inside source port number. Then we are defining inside global IP address and inside global port number, so that and then we are defining that this interface will be outside and this interface will be inside, so that when we'll make such kind of configuration, when we'll open our web browser, our communication will be redirected to exactly this server and to exactly this port number. And now let's have with you the example of next forwarding port in the packet tracer. And in this example, guys, we have with you two servers which are placed on inside local area network. So let me place here a marker that this is our inside this are our private IP addresses, and our computer 0 wants to have access to one of the servers. So we can make actually test. So PC0 can make communication with server 0, and PC0 is able to make test ping with the server 1. First packet lost because of the ARP protocol. And now it's time to open the web browser, and in web browser actually we can type this IP addresses 192.168.10 and 111. So we have server 1, actually it's going to be server 1, and this IP address will give you ability to go to server 2. So let me even rename them because we have some issues with it. So config server, first of all, like this, then this server will be called server 1, and our next server will be called server 2. Well, by using this IP addresses we can reach this servers, but you have to remember that we can have we will have problems in case if we will try to make access to from the public network to local network by using destination private IP addresses. So to prevent the situation, we have to create a NAT translation on our router, so that here we'll have with you such kind of command. In global configuration mode, we'll type the command IP NAT inside source static. Then we'll say that we'll use TCP protocol, and our server's IP address is going to be 10.111, and we'll use its port number 80. So we'll retranslate to port number 80, and then we will define our public IP address, which we have, and it's going to be 111 and 1. I'm typing here 1111, and then I'm typing that its port number will be 8080, for example, or it can be any port number. It can be 8000. And also I'll add here the comment which will make translation to 112 IP address, and the port number will be example as 12. And then I have to provide this configuration into gigabit interface 01. Interface gigabit 01 will be IP NAT inside, and interface S000 will be IP NAT outside. Then I have to take a look, for example, when I will open the web browser, and now I will try to enter by IP address 1111 with the port number 8000, I will reach the server 1. But when I'll type here the port number 8012, I will reach server 2. And also, but also I can reach this servers by their IP addresses due to the fact that I don't have any access lists which are configured. But if I'll implement this access list on my router 1, let me implement it in the. Let me first of all create them, create this rules, and then I will say that interface S000 000 will be using this access list, IP access list, no private addresses, access. Something went wrong here. Access group, no private addresses, and in. And now if I'll try to make this communication again by IP address of original server, I will not have ability to do it due to that fact that access list on router 0 will restrict the communication. But if I'll try to make access by public IP addresses, then it is possible. And also we can make access to our first server by using this IP address. But if we'll try to open first IP address by its original IP address, we will not be successful to do this job. Alright, it's time to also show you how you can make translation of how we can make double translation and use same IP addresses inside local area networks, and at the same time to have ability to communicate with these computers which have the same IP addresses. Alright, let me open my pre-configured double site configs. So in which we have the situation that we have one local area network here, and here we have another local area network. And let me even change my IP addresses. I'll change IP address of computer to the same as I have in another organization, 10 and 111 with prefix 24. And here we'll have we have to change an IP address. Well, I'll start from the configuration of my computer, 10 and 111, and the file gateway will be 10 and 1 because it's going to be IP address of router 1 gigabit 00 interface gigabit 00, IP address 192.168.10 and 1 with subnet mask of prefix 24. And as you see, our PC0 has an IP address 10.111, and here we have server which also has the same IP address 10.111. How these two computers can make the communication between each other? So we have to create one NAT translation here and another NAT translation here. So this NAT will make translation for IP address 192.168.10.111 with port number 80 to IP address 1111 with port number 8011, let us say. And also it will make translation IP addresses 10.112 with port 80 to IP address 1111 and port number 8012. Well, this translation will be happening when information is coming from PC0. It will be retranslated to one of these two servers according to the port numbers. And here we'll also have the translation with you of IP address 192.168.10.111, PC1's IP address, and its port number 80. And then we'll have with you translation of, or even we will not use the port numbers, we'll just translate this IP address into the public address like this. So when information will come to IP address 1112, it will be retranslated to this IP address. So let's try to do it. We can open the notepad, and in notepad we'll just create these comments of router 0 will have IP not inside source, or you know that we can just copy previous. No, we didn't create it. Okay, forget about it. IP not inside source static, and then we are defining our IP address. But before we'll define them, we'll say that TCP and IP address 10.111. Then we are defining the port number 80, and then we are defining our public address with port number 8011. I'll copy this comment and paste it here, and all I need to change the IP address here, and I need to change the port number here. And then interface gigabit 01 IP not inside, and interface S000 IP not outside. These comments will be configured on router 0, and then I have to make configuration of IP not inside. Source static will be 192.168.10.111, which will be translated to this IP address like this. And then interface S000 IP not outside, and interface gigabit 00 IP not inside. Let me implement these two comments, sets of the comments to my routers in the global configuration mode. Oh, something went wrong here, so let's pay attention on this. It's saying that here we have the problem, so that I have to retype it to find the problem. Source. Let me go to global configuration mode, IP not inside source static TCP, and then 192.168.10.111, and then the port number 80. Alright, and then 1111. Yeah, here it is. So I mistakenly typed here the column, but I don't have to do it. So let me take it off. I had to do it in this way. So let me just copy it back and let me paste it in the global configuration mode by using button paste. And then I have to copy this comments, and I have to paste these comments into routers one's global configuration mode. And IP not inside, so here I have also a problem in the syntax. Oh, just a moment, inside there have to be inside. And then if I'll type the command show run, I have to see here my not translation. Okay, and in show run running configuration file of router 0, I have to see also not translations. So I had previous configuration, so let me delete it. By using command no and no. So it was done before I started the presentation, sorry, so let me delete it. and I'll do it in the global configuration mode and do show IP NAT, do show run comment is shown. I had to do it here, sorry, in router 0. And let me paste it here. So I delete them. Show running configuration file is showing me that I have these translations. And when I'll try to make a communication from PC 0 to server 0, so let me open the simulation, and in simulation I will use the DHCP protocol, so that from computer 0 I'll try to make the communication with IP address 1111 and 8011. So when I'll press enter, my HTTP packet have to be generated from PC 0, and then PC 0 have to send it to the router, so that when router 0 will reach, when packet will reach the router 0 have to retranslate this communication, and as you see now our destination IP address will be 10 and 11. So that if we'll take a look for this situation from one more time from the beginning, we will open this IP address with port number 111, and you see that our packet is generated, and inside our packet we have source IP address 10 and 111, destination IP address 111 and 1. Well, this packet reach router 1, and when this packet leaves the router 1, its source IP address now changed to 111 and 2, to destination IP address 111 and 1. After this router will receive it and forward it to switch 0, its IP addresses will be changed one more time, and now its source IP address is 111.12, but destination IP address is 192.168.10 and 111. So that when server 0 will give reply, inside reply will have as you the source IP address 10 and 111, destination 111 and 2. And when this router will resend the information to router 1, its IP addresses will be changed one more time, source and destination, as you see here. And when our router will resend the information to destination, to PC0, its IP address will be changed again. So destination will be one more time 10 and 111. This is how we can make configuration of port forwarding in IP version 4 DHCP. This is the end of the presentation which I want to show you about the NAT translation. I hope that this video been informative for you, and if you like this video you can subscribe to my channel to see all fresh available videos from me. See you.